Good evening, everyone. My name is Rukku Raju. Welcome to KP classes, another live section regarding geology. So, today's live section, we'll be discussing a topic under metamorphic petrology. So, over here in today's section, we'll be discussing the Facies series coming under metamorphic petrology, like metamorphic Facies series terminology. So, what is metamorphic Facies series? Metamorphic Facies series means it is a sequence of facies that occurs across a metamorphic terrain due to difference in the pressure and temperature condition. Pressure and temperature, P by T, depending upon the different pressure temperature condition, there will be different metamorphic terrains, different metamorphic situations will be there. Facies will be occurring. Sequence of facies will be occurring depending upon the pressure temperature condition in that particular terrain. So in order to describe a sequence, we have to study about the change in the metamorphic conditions, like how pressure and temperature variation is happening in that particular area. Based on that, we have to discuss the sequence of metamorphic facies over there. So each facies series is characterized by the development of a particular sequence of individual facies, with each facies stable at a specific range of temperature and pressure condition. So let's discuss about the concept of Facies series. So Facies series provide the key information about the progressive pressure, temperature, time conditions, like PTT path is defined, well defined, or can be discussed on the basis of Facies series. As the tectonic setting in which metamorphism is occurred, so in different tectonic settings, the Facies series will be different based on the PTT conditions over there. So this metamorphic Facies series is defined by the scientist Miyashiro in 1994, based on the pressure temperature condition, pressure temperature gradients. So let's discuss the metamorphic Facies series defined so far. So far there are three different situations. There are so far 5 metamorphic series are there, which will be falling under three different conditions of low P by T, medium P by T, high P by T series situation. Low P by T series, medium P by T series, and high P by T series. Low P by T series group consists of two low pressure and high temperature Facies series. P by T means pressure by temperature ratio. Low P by T series will be there. Low P by T series where the pressure terminology is comparatively lesser than the temperature. Temperature will be high whereas pressure will be low. That is low P by T series. So there are two different low P by T series, Facies series. So under low P by T Facies series, there are two terminologies. First one is the very low P by T, very low P by T contact metamorphic Facies series. Facies series, and the second one is this like comparatively higher P by T series, that is Buchen metamorphic Facies series. These two are coming under the low P by T series. Then there is medium P by T series. In medium P by T series, both pressure and temperature are important factors. Both of them are moderate P by T gradients is characterized by Barrovian facies, Barrovian metamorphic facies. Barrovian metamorphic Facies series. Then the next one is high P by T series. In the high P by T series, there are two different groups are there. First one is the Sandbagua Facies series. Sandbagua and Franciscan. There are two. Both of them comes under the high P by T series group. First one is the Sandbagua Facies series. Second one is the Franciscan Facies series. So these are the metamorphic facies series known so far. Like 5 different metamorphic facies series are there. First one is the very low pressure contact metamorphic facies series. Then somewhat higher P by T Buchan Facies series, Buchan or Abukama Facies series. Then the next one is Barovian Facies series, which is medium P by T or moderate P by T condition. Then the high P by T situation, very high pressure and low temperature condition is, there are two different situations. First one is the Sandbagua Facies series. Then the second one is the Franciscan Facies series. So you can see all these Facies series. If I draw them in a phase diagram, this is how they looks like. So you can see the phase diagram over here. In the phase diagram, look at this is pressure versus temperature phase diagram. You can see low P by T series over here. This is the moderate, so this is the low P by T, this is moderate P by T, and this is high P by T situation. Low P by T series will fall over here this particular way. This is the moderate P by T will fall over here this particular way, or high P by T will be falling over here. This is the high P by T situation. Now next one is, you can see each the direction in which this each series will be following. Like you can see this is the contact facies series. I'll show you. First of all, let me the kyanite andesite sillimanite phase diagram is actually shown. So this is andesite, kyanite and sillimanite situation, kyanite and sillimanite curve over here. Now first you can see the, let's see the contact metamorphic facies series over here. The low P, very low contact metamorphic facies series, very low pressure contact metamorphic facies series. Now when it comes to the low pressure contact metamorphic facies series, in the low pressure contact metamorphic facies series, it consists of a relatively low pressure situation. Pressure will be less than 2.5 kilobar. This much lower, like 2.5 to 8 kilometer, 8 kilometer, like 2.5 kilobar means 8 kilometer depth pressure. So a pressure of average like 2.5 kilobar or less than that, it will be the pressure situation of a contact facies series, contact metamorphic facies series. So here the geothermal gradient for contact metamorphic series will be very high. Geothermal gradient situation will be greater than 80 degrees Celsius. Here it is a very low P by T. Pressure terminology is very low. Ratio of P pressure by temperature. P pressure will be very low, whereas temperature will be comparatively very high condition. Very low P by T situation. So the geothermal gradient will be greater than 80 degrees Celsius per kilometer. This will be the geothermal gradient where we will be getting a contact metamorphic facies. Contact facies series will be there. So this is associated with contact metamorphism. In contact metamorphic aureoles, we will be having contact facies series will be present. The depending upon the depth, this contact metamorphism usually happen at shallow condition. In the deeper depth, the contact aureole will not have a prominent distinction between the nearby terrain, the country rock, because there already the temperature will be very high. Hence, the rock will not undergo much change because of the plume. Because of the contact metamorphism, or because of the plume that is formed over there. Or in the intermediate level, contact aureole will be larger comparing with the shallow situation. That is the epizone, mesozone, catazone, contact aureole terminologies actually. I'm not going into that in detail. So whenever we discuss the contact metamorphic series, they are associated with the low pressure assemblages of mineral. So they will be associated with these facies like albeit, epidot, hornfels facies, like starting from zeolite facies, prahanite, pumbelite facies, or zeolite to directly it can go to zeolite facies, prahanite, pumbelite facies, albite, epidot, hornfels facies, hornfels species, pyroxene hornfels species, and sanidinite species. This sanidinite species is a rare situation. Very rarely sanidinite species will be forming. They are mainly associated with xenoliths or very high low pressure conditions. Other than that, these pyroxene hornfels, hornblende hornfels, albate epidot hornfels, all these species will be there in the contact aureoles. So in a contact species series, the sequence of facies will be progressing from zeolite to albite epidot hornfels, hornblende hornfels, pyroxene hornfels, and the rare situation of sanidinite facies. So you can see the pressure value is very low, whereas the temperature will be increasing. So because of this very low P by T situation, the contact facies series, this arrow over here, it has a very low angle. This has a very low angle which reflects the progressive increase in the temperature without increase in the pressure. There is no increase in the pressure happen, only the temperature is increasing. That's why contact facies series has a low angle slope. The slope of the contact facies curve over here, the line that defines contact facies series, is very almost horizontal. So at this high temperature area over here, this will be associated with the area in the contact aureole which is much more closer to the, or which has a close proximity to the intrusion. At that particular area, you will have this high temperature situation will be there. Then away from the intrusion, the grade will be decreasing, temperature will be decreasing. So you will have much more lower grade area, lower temperature area will be there. When you move away from facies will be there, when you move away from the contact aureole. So here contact facies series, it's usually associated with contact metamorphism, or wherever there is a hot pluton intrusion happen to a country rock. For example, in a convergent margin ocean spreading zones like mid-oceanic ridge areas, hot spots, in those areas or localized aureoles around the intrusion, here this contact facies series will be common. So contact facies series will have a very low pressure and it can go up to high temperature. Hence the P by T will be very low over here, and they are usually associated with hot magma intrusion. The facies series are hornblende, first from zeolite facies to albite epidot hornfels facies. Then hornblende facies will be progressing into pyroxene hornfels facies. In rare condition, at high temperature situation, it can go even up to sanidinite facies. So here they are associated with orogenic belt at convergent plate boundary also. Wherever there is a magmatic intrusion, something happen, it can also be associated with convergent plate boundaries, orogenic belts. So next one is, so this is the Hornfels series. This contact facies series is also called as Hornfels series. defines a low pressure, high temperature metamorphic facies series, low P by T. So mineral assemblages over here will be associated with these metamorphic facies. Okay. Now next one is, so that is about the contact metamorphic facies series. Next one will be next higher one. So that one we discussed about the very low pressure contact metamorphic facies series is completed. Now after this situation, next is Buchan metamorphic facies series, or it is also called as Abukama facies series. Buchan or Abukama facies series. Buchan is a the terminology Buchan is actually given from the terrain in Scottish Highlands, where the metamorphic situation over there, the geothermal gradient is ranging from 40 degrees Celsius to 80 degrees Celsius per kilometer. This is the geothermal gradient in that particular area, and the pressure is actually comparatively higher than the contact facies series. So this one is having a higher P by T ratio than contact metamorphic contact facies series. That's why you can see over here in the curve, the after the contact metamorphic facies series, the next one, the Buchan one has, this is the Buchan facies series curve over here. Buchan facies series curve, which is much more steeper than the contact facies series, much more steeper than the contact facies series. Why? Because of the high P by T condition. Give it a moment, the screen will be clear. Yeah, screen is clear actually. So, so that is why the Buchan facies series over here, because of the much more higher P by T ratio than the contact facies series. Buchan facies series, the slope is much more steeper than the contact facies series. Now we are discussing about the Buchan facies series in detail. Now when it comes to the Buchan, yeah, Abukama terminology is associated with a terrain in Japan, which also falls under the same pressure temperature condition of low P by T series. Now when it comes to these facies, Buchan area is associated with northeastern part of Scotland. Abukama is associated with Abukama region in Japan. Now, this facies over here, Abukama or Buchan facies series, both of them are defined by low to moderate P by T condition. Low to moderate pressure by temperature condition. So over here, this Buchan facies series and Abukama facies, Buchan or Abukama facies series is mainly defined in the pelitic rocks in this Scottish Highland area or in Japan region. The terrain over there is mainly consisting of pelitic rocks, and there the temperature over there is comparatively lower. Hence, the temperature content value is comparatively lower. The high temperature situations, like high temperature conditions, sorry, high pressure polymorph of andalusite sillimanite, that is the kyanite is the high pressure polymorph of aluminum silicate, which is actually not present in this particular area. So here in the Abukama region in or in Buchan area, we won't be getting the high pressure polymorph of aluminum silicate, or kyanite won't be present in this particular terrain. Now when it comes to the metamorphic facies sequences over here, though it is a low P by T condition and grade is also lower over here, here the facies series will be zeolite prehenite facies, zeolite prehenite, then pumbelite, zeolite facies, prahanite pumbelite facies, then it will go to green schist facies. From green schist facies, it will be moving to amphibolite facies, and if the temperature is very high and the pressure will become comparatively moderate, from amphibole facies it can go to granulate facies also. So this is the facies sequence of the Buchan facies series, starting from zeolite facies, progressing into prahanite pumbelite. From there it will progress into green schist facies, and then from there it will be going to amphibolite facies series and moving towards the granulate facies series. So here in the pellitic terrain over here, the metamorphic terrain can be divided into few zones. Here in the Buchan series, we mainly have three different zones are there: chloride zone, Andalusite zone, and sillimanite zone. Chloride, Andalusite, and sillimanite zone are the three major zones that are present in the Buchan facies terrain. Buchan terrain in the Scottish Highland. So over here, they can represent higher temperatures, but only moderate increase in the pressure. Pressure will not increase much, only the temperature value can increase. You can see the pressure value exactly. If you look at this over here, the temperature is ranging from very low value of zeolite, like 150 200 degrees Celsius of zeolite, till 700 800 degrees Celsius of granulite. The temperature can move, but when it comes to the pressure value will not be ranging much, it will not be increasing much, it can only increase up to a moderate value. So that's why Buchan or Abukama comes under low P by T series. It comes under low P by T series. So here, though the pressure terminology is higher than when you compare it with contact facies series, pressure is there, or deviatoric stress is acting onto the terrain. So because of the deviatoric stress acting over there, the rock will be mainly foliated, or deformed rock formation happens because of the non-uniform stress. Not always foliated. If there is deviatoric stress acting onto the terrain, it will cause foliation to the rock. Non-foliated Buchan facies series rocks can also occur wherever there is less pressure is there. If pressure is comparatively higher, it can give rise to uh, क्या बोला है, foliated rocks. Now when it comes to the next series, that is the high P by T series. So low P by T is over. Next is high P by T condition, medium P by T, higher than Buchan, medium P by T facies series, that is Barrovian facies series terminology. So over here you can see Barrovian facies series over here. This is the Barrovian facies series. Barrovian facies series demands a medium P by T situation. So medium P by T situation, and hence though it is a medium P by T, in Barrovian facies series it is medium P by T situation, and the geothermal gradient over here will be ranging between 20 degrees Celsius per kilometer to 40 degrees Celsius per kilometer is the temperature range. So here there is an increase in both temperature and pressure happen. So this is actually associated with regional metamorphism. Associated with regional metamorphic situation, both temperature and pressure is increasing, progressive increase in temperature and pressure is happening, hence it is associated with regional metamorphic conditions. This Barrovian facies series, actually type area is in the Scottish Highland. The terminology Barrovian is from a geologist called George Barrow, who have defined the particular facies series, medium P by T facies series in the Scottish Highlands. So here in the Barrovian facies series, let's see the sequence of sequence of the facies is present over here. Here also in Barrovian, it starts from zeolite facies, and then from there, from zeolite facies it moves to prahanite pumbelite facies, and then it will become greenschist facies, amphibolite facies, and at high temperature and moderate to high pressure it can go to granulate facies. So this will be the progressive sequence of Barrovian series. Barrovian series facies sequence will be this. Whereas when you look at the Bookend series, it will be like in a much more lower pressure temperature situation, right? It will be over here, like its growth will be over here in a much more lower pressure condition. Barrovian will be associated with high pressure also, high temperature also. It can go up to high pressure and high temperature condition. When it comes to the different Barrovian zones, uh, terminologies with increase in the grade, first one will be chloride zone, then biotite zone, garnet zone, storlite zone, kyanite zone, and sillimanite zone. Biotite and chloride and biotite zone come under greenschist facies. Then garnet, storlite, and kyanite will be coming under sillimanite. Also will come under amphibolite facies. Higher sillimanite zone terrain will be a part of sillimanite zone can also define granulite facies if the temperature is very high. Now, when it comes to Barrovian facies series, here the mineral assemblage is entirely different from Buchan facies series. Even though Buchan facies series also pass through the same metamorphic facies, but the mineral assemblages are entirely different because of the high P by T ratio of Barrovian zone. Because of high P by T ratio, mineral assemblages are different from the Buchan facies series, which is low P by T facies series. The here you will be having, because of high pressure and high temperature, will have andalusite can also be present along with high temperature polymorph of sillimanite. Low temperature polymorph, sorry, andalusite won't be there. High pressure polymorph sillimanite and kyanite. Sillimanite is high temperature, high pressure is kyanite. Both of them can be present, but the low pressure polymorph of andalusite won't be present in the Barrovian series. Whereas in Buchan we saw that andalusite and sillimanite is possible, kyanite will not be possible. Kyanite is absent in the Buchan facies series mineral assemblage. Whereas in Barrovian facies series mineral assemblage, andalusite will be absent. Sillimanite and kyanite will be present in the Barrovian facies series mineral assemblages in pellitic rock, when we discuss that for pellitic rock. Now, when it comes to the Barrovian facies series, look at the slope of the curve. This slope of the curve will be much more steeper than the Buchan or contact facies series, simply because of higher P by T ratio than the other two. Low pressure situation. The Buchan and contact facies series, both of them have low P by T than the Barrovian facies series over here. Barrovian facies series is can develop in response to both increase in temperature and pressure because of orogenic belt thickening at convergent plate boundaries. So collisional orogeny terrains are mainly will have a Barrovian facies series metamorphic mineral assemblages. So here Barrovian facies series rocks usually show foliated texture structures because of the high non-uniform pressure applied to the metamorphic rocks over there. So that's about the Barrovian facies series. Next is the high P by T condition. Next is the high P by T facies series. So Barrovian is also completed. Next is the contact facies series, Buchan facies series, Barrovian facies series is done. Next terminology is the high P by T facies series, and there in the high P by T facies series, first terminology is Sandbagua facies series. First terminology is the Sandbagua facies series. In the Sandbagua facies series, these are produced under geothermal gradients. They are produced under geothermal gradients of 10 to 20 degree Celsius per kilometer. Sandbagua Facies series is forming under geothermal gradient of 10 degrees Celsius per kilometer to 20 degrees Celsius per kilometer. So you can see the geothermal gradient has dropped down. Geothermal gradient has dropped down from 10 to 20 degree Celsius per kilometer. So here's Sandbagua belt in Japan. Sandbagua belt of Japan has the same metamorphic facies series. So from there we have used the term like Miyashiro as geothermal geologists have used the terminology of Sandbagua belt over here to name the Sandbagua facies series. Now when it comes to the facies sequence in Sandbagua facies series, you can see, so this one follows, this is the Sandbagua facies series. You can see it is much more steeper than the Barrovian Buchanan contact facies series. Now, what is happening over here in the Sandbagua facies series? It is the facies sequence is in such a way that it starts from zeolite facies, prahanite pumbleite facies, then it directly goes to the blue schist facies, and then from blue schist facies it can sometimes cease, like in some cases it will go to green schist or amphibolite facies further. So how will be the path? Path will be, it will be initiated from the zeolite facies over here, zeolite to prahanite pumbleite facies, zeolite to prahanite pumbleite facies, and then from here it will go to blue schist facies. From blue schist facies it will be followed back to green schist and amphibolite facies. This will be the path sequence of facies, progressive sequence, progression in sequences, a progression of facies in the Sandbagua facies series, starting from zeolite, prahanite pumbleite, it will go to blue schist facies, and then further it can be followed to green schist and or amphibolite facies. So here there is a rapid increase in the pressure happens. You can see temperature increase is comparatively lower, but pressure increase is much more rapid. Look at the slope. Compare it with Barrovian Buchanan contact facies series. The slope is much more steeper over here in the Sandbagua. Because of the, like from the slope itself, we can understand that the pressure increase over there is much rapid when you relate it to the temperature. So here progressional regional metamorphism happen at convergent plate margin. So during that particular case, there is a rapid increase in the pressure happens comparing with the temperature. So because of this rapid increase in the pressure, Sandbagua facies series will be forming. Sandbagua facies series will be forming. There is huge amount of pressure, high P by T. So pressure value is much higher. So because of this high pressure condition, rocks within the Sandbagua facies series will be highly foliated and highly deformed. Highly foliated and highly deformed. So this blue schist facies is very peculiar over there. Glaucophane and all these blue schist facies mineral assemblages will be very common in the Sandbagua facies series. Higher P by T ratio than all the other, like whatever we have discussed. Barrovian, Buchanan, contact facies series, when you compare, P by T ratio is much higher. The pressure increase in pressure is much rapid. Hence the curve, like the sequence of Barrovian series is much more steeper than the all other facies series that we have discussed now. So it is very high pressure and very low pressure. Very high pressure and very low pressure situation. This is high pressure, very high pressure, and it has gone up to an amphibolite facies temperature, right? Like it is, we can see over here. See, it has gone up to the temperature, like amphibolite, it can come up to this temperature. That is also possible. Next one is Franciscan facies series. Look in the Franciscan facies series. Here the pressure is very high, but that has not gone up to a high temperature. So Franciscan facies series is very high pressure and very low temperature. So the P by T ratio will be much higher over here. It will be the maximum. P by T will be very high. The ratio of pressure to temperature will be very high for the Franciscan Facies series. So when you compare with San Bagua and Franciscan, both of them are high P by T Facies series, but the pressure value for Franciscan will be much higher, and the temperature range for Franciscan Facies series is very low. Whereas San Bagua, comparatively low pressure and high temperature it can go. So P by T ratio will be much higher for Franciscan Facies series when you compare it with San Bagua Facies series. So here San Bagua Facies series is usually associated with slower subduction zones, wherever like giving rise to more time to heat up as pressure increases. In that case, San Bagua Facies series will be forming. Okay. Next terminology is Franciscan Facies series in detail. Franciscan Facies series. In the Franciscan Facies series, they develop where the geothermal gradient is less than 10 degrees Celsius per kilometer. So the geothermal gradient of over the terrain will be much lesser. It will be less than 10 degrees Celsius per kilometer. So here they are will have an unusually high P by T ratio. P by T ratio is an unusually very high P by T ratio will be there. The trajectory of sequences, Facies sequences, if you look, they are much more steeper than the San Bagua Facies series. Like we can see the Facies will be for Franciscan Facies series. The progressive metamorphic Facies will be from zeolite Facies. From zeolite, it will go to prahanite pumbelite, blue schist, possibly to eclogate. So this will be the path. Like it will be moving from zeolite to prahanite, pumbelite, and blue schist to eclogate. This will be the path of Franciscan Facies series. So in Franciscan Facies series, you will be getting the eclogate Facies actually, eclogate Facies. So it is a very high, unusually high P by T ratio will be there. The metamorphic Facies progress from zeolite to prahanite pumbelite to blue schist, then possibly to the eclogate Facies situation. Then you can see that there is a rapid increase in the pressure relative to the slow increase in the temperature. The temperature gradient is less than 10 degrees Celsius per kilometer. So that increase in the temperature gradient, like less than 10 degrees Celsius per kilometer. So you can understand how slowly the temperature increase happens in the Franciscan Facies. Whereas when you look at the pressure value, pressure will be increasing much rapid. Very rapid increase in the pressure happen, whereas very low increase in the temperature will be taking place. The gradient, temperature gradient is geothermal gradient will be less than 10 degrees Celsius per kilometer for Franciscan series to takes place. So because of this high P by T condition, the slope of the curve will be the slope of this progressive increase in the San Franciscan Facies series is much more steeper than any other Facies series. And next is about the high pressure polymorph of aluminum silicate. Obviously, here the pressure is very high. Because of the high pressure, there should be kienite formation is must. Kienite, which is the high pressure polymorph of aluminum silicate, is very common over here, and along with that, phengite will also be common. if it is a pelitic rock, both phengite and the high pressure polymorph of aluminum silicate, that is kyanite, both of them will be common in the Franciscan Facies series situation. Now the rocks are highly deformed and highly foliated because of the high pressure acting onto the terrain. High pressure acting onto the terrain. So these are the terminologies that are associated with contact metamorphic the metamorphic facies series terminologies. So what are the metamorphic facies series that we have seen just now? We saw about contact facies series, Barrovian facies series, Sanbagua Facies series, Franciscan Facies series. These are the 5 different Facies series in which contact Facies series is associated with low grade metamorphic low P by T situation. Then the Buchan Facies series is associated with low P by T but higher than contact Facies series. Barrovian Facies series is associated with the terrain that has medium P by T condition. Sandbagua Facies series is associated with high P by T. Franciscan Facies series is associated with very high P by T condition, very high P by T situation. So all 5 different types of Facies series are explained. The sequence progression of Facies associated with each series is also explained. Depending upon the protolith, the mineral assemblage will be different. But mainly like for Barrovian, Buchan, Sandbagua, they are defined for pelitic rocks, like the type area, Barrovian Scottish Highland area, which defines the Barrovian Facies series. Buchan also defined by the northeastern part of Scottish Highland. Sandbagua is from the Japan belt, Sandbagua belt. Abukama is also from the Japan belt over there. So all these like pelitic rock I have discussed, from where you will get kyanite, from where you will get where are the chances of getting andalusite, sillimanite and kyanite based on the pressure and temperature terminologies. Detailed metamorphic mineral assemblages associated with each facies will be provided in the class for the for the students over here. So if you want to join our KP classes for detailed understanding of every subject associated with geology, you can join us. You can use the link given in the description box for getting a demo class, or if you have any query related to our coaching, the subjects that we cover over here, the pattern of our teaching, anything, you can contact us. We'll clear all your doubts regarding that. So thank you so much. We'll meet you with another live section. My name is Rukku Raju. Any doubts related to geology, you can contact us. Anything related to this video, you can comment down. Thank you.